Hi everyone. Today we're updating you on everything WICDI has been up to since last year's WLIA. I'm Melanie Coles. I'm the Outreach and GIS Specialist for the WICDI project.
Hi, and I am Genevieve. I am the research specialist for this project.
And like I said, we're here today to just update you on everything we've been up to since the last WLIA. This time last year, we were presenting in Middleton, which is crazy. We've all been through quite a year, but luckily it seems that there's some light coming at the end of the tunnel, which is nice. And we've definitely learned a lot about virtual presentations along the way. So everything should go smoothly today. If you have any questions, please put them in the chat and or stick around to the end of the presentation so we can try to answer those for you. But I think we are ready to launch right into it. So for anyone who needs a refresher or is new to the project, WICDI stands for Wisconsin Coastal Management Data Infrastructure. And WICDI is a NOAA-funded project of special merit, which is thus funded through a grant. And it's operating out of both the Wisconsin Department of Administration and the State Cartographer's Office, so kind of jointly managed. The project's initial 18 months is coming to an end in March, actually, and it's going to begin its second 18-month iteration, which was awarded this year. Genevieve and myself are the main project staff, and we work under Jim Giuliano, the State Geographic Information Officer, as well as Howard Berrigan, the State Cartographer. The WICDI project formed as a result of the 2016 and 2018 heavy rains that caused severe flooding across northern Wisconsin, especially along the Lake Superior border. The project PIs at the time noticed that culvert inventories and related abilities varied widely across the area, resulting in making it harder for a good and unified flood response, as well as timely culvert upgrades and other pressing concerns. So they wanted to kind of de-silo a lot of the culvert data housed by different organizations and provide a space for more collaboration and for more people who were interested in getting a better start on inventorying their culverts to really be able to learn and get involved. So the WICDI project developed out of this idea, and we created a community of practice centered in that northern Lake Superior region, but expanding outward across the state and even out of state. This community is slowly growing now. It was quickly growing at the start of the project, and now we're kind of finding a happy, sweet spot of around 100 or so members. And it really helps us focus and develop our project goals to make sure that we're meeting the needs of the community at large. The project main objectives, which you can see on the slide here, are to create a shared culvert data set, establish that data set within a collaborative support environment, provide technical assistance to communities by using our data and tools, and finally support FEMA-funded culvert replacement and improvement, as well as other government-funded culvert upgrades and better guarding against flooding. And just wanted to remind everyone that we are talking about culverts, not culvers, although culvers is great, and we'll gladly accept sponsorships from Scoopy anytime.
So we've accomplished a lot with the project since we last presented at last year's annual WLIA convention. If you've attended some of our workshops since then, you'll recognize quite a lot of this information that we're going to present. But for everyone else, we can catch you up to speed. By last year's annual meeting, we had collected several culvert datasets from our community of practice. We plan to combine all of the attributes from those datasets data sets into one master list. We then were going to send out a survey to our COP asking them to rank the attributes by usefulness. We expected different organizations to have very different rankings, and we planned on using the survey results to generate a universal schema of attributes that we could then use to create a large data set of culvert inventories across the state. And to give you an idea of the variety of culvert data we collected, there are quite a number of data sets when we started the project. You can see the data sets are different in terms of number of points. It's hard to see on the slide, but you can tell by the colored blobs in the areas of who was collecting and how the data would be used. For example, the Department of Transportation versus the Wisconsin Wetland Association. Our project area is made up of Ashland, Iron, Douglas, and Bayfield counties, but we wanted to use the data that extended beyond those counties as well. This will make the project even more valuable on a statewide and even the Midwest regional level.
So the data sets from the previous slide were all things that we have had or been aware of for a while. But we also wanted to put out a call for more recent or updated data sets in our focus area, especially along Lake Superior. From this data request, we got an additional 7 data sets from our community of practice. Again, you can see a wide variety of sizes of inventory, ranging from 300 to 14,000 points, and a variety of collectors from the counties to the Forest Service. These data sets, additionally, really enriched our master list of attributes and ultimately were really helpful as we tried to design a schema that was as inclusive as possible of everyone's different needs relating to their culvert data.
So taking in all of the data sets and attributes, we took all of the 22 or so data sets and broke them out all into their individual attributes and then combined them into one large spreadsheet. And there was close to about 200 attributes. Then we began to compare all of the attributes and combine the ones that were the same or used different words for the same meaning. So for example, pipe length and culvert length are referring to the same thing. We also did our best to separate out the attributes into broad categories like location information, culvert information, road information, and you can see that in the 11 different columns that information is broken out into.
So after Genevieve had gone through and made that extensive cross-reference attribute list, we wanted to use the list to create a survey to find out which attributes the community of practice needed most. Spoiler alert, the answer turned out to be pretty much all of them. But we had to find that out for sure, so we created this survey and asked participants to rank which attributes were core, useful, or not useful for their specific needs and their organization's goals. In addition, there was space for respondents to suggest additional attributes that we might have missed and make comments on our survey as a whole.
So for our survey, we got 23 respondents, and we broke them down into 4 different categories that all had like similar responses and what organizations they came from. So they were 5 asset management, which were the counties and the DOT, around 12 ecological, which was more like the DNR and the USFW. There were 5 hydrological respondents, the USFS and the NWRPC, and 1 damage respondent, which was WEM. So once we broke down all of these survey results, we imported them into Excel to be processed. And one thing that we did was we color coded all of their results to make the results a bit easier to view and sort through. And after that, responses were tallied and graphed. And this way we were able to identify core, useful, and not useful for our inventory. And this is one of the graphs that we made. So you can see that like latitude and longitude and county were all very important, but the rest of them in this were considered useful or not useful. So that's a lot of how they were broken down.
Yeah, so as I mentioned earlier, the survey didn't really help us narrow down our attributes in the way that we had originally planned, but instead we found that many attributes were ranked as useful by multiple types of organizations. Respondents also commented often that they recognized certain attributes' usefulness even when they themselves didn't currently collect those attributes. We also didn't find a select group of core attributes from the survey. Core actually tended to be much more dependent on the type of organization. There were a very small number of very basic attributes that everyone did consider to be core. These were mainly location-based attributes. So we all agree that if we're going to be inventorying culverts, we need to know where they are. We also didn't find, we did find that some very common and well-known attributes for certain organizations were almost never mentioned or not on the radar of other organizations, which is consistent with what we were thinking about different people's needs and goals. So overall, we were getting a better understanding of the types of specialized knowledge that can come into play in different types of culvert inventories. While these responses did throw us for somewhat of a loop, they were extremely helpful in developing our culvert schema and database. Responder comments especially were super useful here. They stressed the importance of culvert maintenance history, something that we've known to be essential for receiving aid in upgrades and replacements. We also used all this feedback to begin developing our culvert data model. So after processing all of those survey results, we generated a data model that contained all the attributes aside from those deemed not useful by all of the respondents. And we grouped the attributes as best we could by their use cases and the demographic interested in them, which you can see here. We tried to break it down in kind of reasonable groups. We originally intended to use this to build a relational data model in which all of these tables would be separate and kind of joined together independently, but creating the relational model proved to be a bit difficult for our level of computational skills. It was requiring a lot of work in Postgres and SQL and other things that we weren't as familiar with. So ultimately, we switched to a more standard geodatabase model, which is a flat file, but can still provide all the things that the community of practice is interested in. Things like querying the data, looking at specific areas or specific dates, breaking it down by all the other attributes, etc. We do expect these groupings to change over time somewhat, and we'll probably add and remove attributes as we refine the model. But this, what you see here, is considered our version 0 schema for our database.
Speaking of the WICDI database, once we tweaked the version 0 schema enough to be happy with it, we were ready to start loading in all of our data sets. So here's an example of our process of, well, here is, but you'll see in the next few slides of our process of putting data sets into the geodatabase. So this snapshot shows our database from a few months ago. So not all of our data was loaded in, but you can see the feature class is coming together. We assembled the database in ArcMap using a tool called the Simple Data Loader to load all of the individual data sets into the schema that we created. So, here you can see a snapshot of the Simple Data Loader tool. It was quite a tedious process where we had to choose each data set to import and then comb through all of them to find the attributes to match the ones in our schema. Many did, but several fields were too specific to make the cut for this version of the database. Things like cost of removal or lamprey index for invasive species vulnerability. However, some of these more esoteric fields were able to be brought in through our different comment fields. This is an example of something that may be tweaked as we update the database.
So after mapping the fields, we performed any necessary conversions, like a string to a numeric field, and we also added fields of our own. For example, we added to every data set we brought in, we added an original source field, which helps us keep track of that data set within the database and allows us to easily separate it out and look at just that data set if we want to, although it is fully assimilated into the schema of the database. We want to make it easy to query out these specific data sets as efficiently as possible because our plan is to have our database be so large. And finally, we use the Simple Data Loader to bring in each data set, matching up all the fields that we wanted to bring in. Of course, also troubleshooting errors that inevitably came up and fixing anything that we missed along the way. But when it eventually worked, the data set would show up in our geodatabase with a perfectly matched schema. We brought each data set in individually first for safety, and then loaded all of them together into a final feature class to create version 0 of the database. And here's a screenshot of our attribute table. As you can see, this is another older snapshot from late December or early January. We only had 6,600 points in our database at this time, but this still gives you a good idea of what our attributes look like. As you can see, not every data set contains every attribute in the schema, of course. So they just show up as null values if that inventory didn't contain, for example, inlet type and outlet type. And we don't want to mandate any attributes for collection. We would probably like to eventually suggest attributes to collect, maybe through something like a Survey 123 form. And that is likely going to be a part of our second iteration of the project.
I got to remember to unmute myself. Sorry about that. So here's our completed of version 0 of our database. Most of those points that you can see in this image are from the Fishworks dataset, which covers the entire Great Lakes area. So if you take the Fishworks and the DOT data out, there are about 18,000 points, which is still pretty impressive. And our most recent addition to the database is the updated set of the Culvert Asset Management Project data from the DOT. Altogether, we think this is going to be a really valuable resource for all of the COP to be able to compare all of the inventories and potential culvert locations into a standardized fashion. And after our presentation, we will be switching over to a browser window and kind of exploring the WICDI database in ArcGIS Online.
So we are really excited and very proud of our work in creating this WICDI database, which we've just shown you. But of course, this is just the beginning. The database is currently living on ArcGIS Online, as Genevieve has mentioned, and we would like to make it public for community members to view and explore and download soon. We also plan to work closely with our community of practice in the second round of the WICDI project, offering in-depth explanations, walkthroughs, and whatever other resources they might need to become more involved with our database. As we mentioned before, we will almost definitely end up changing our schema slightly over the course of the next year, but hopefully only small tweaks here and there, nothing major. We would like to plan out a schedule for rolling out those changes to kind of a plan to when to have V1 of the database be ready to release. And most importantly, we want to continue to solicit feedback and find ways that this database can be useful to community members who might be interested in collecting their own inventories, either for the first time or as part of an update to their regular scheduled inventory plan. So I just wanted to thank everyone.
We want to, thank our project team and all of our colleagues at the State Cartographer's Office and the DOA for their help and all of their hard work.
And feel free to head to the WICDI website for more information on the project, and stick around after our presentation for questions and to see our database. Thank you so much.
Yes, thank you.